In this video, we're going to see the last type of isomer for grade 12 chemistry. So remember, we saw that isomers can be constitutional, they can be stereoisomers, and if they're stereoisomers, they can be diastereomers, in other words, cis trans. But another type of spatial arrangement variety you can see is the enantiomer. The enantiomer is basically where you just have a mirror image molecule of another, almost like your left and right hand. So what happens is, let's take a look at this molecule here. This is a molecule. Let's call this A. This is B. You'll notice that you have a carbon, and on that carbon you have 4 different groups around that carbon. And so this carbon here, very similar, 4 different groups. So it's actually the same groups as molecule A, but they're arranged in a mirror image form. And you might think, well, aren't they the same? Well, not quite. Think about your left hand and right hand. Your left hand and right hand are mirror images of each other, and you can never directly superimpose them onto each other. You can never make it so that your right hand will lie perfectly onto your left hand with all fingers matching up and all components matching up. Your thumb will always be on one side. Your thumb on your right hand will be on one side, and your thumb on your left hand will be on the other side, and they'll never be able to be imposed on each other. And it's the same thing with these molecules here. It's almost like they're the left and right handed versions of each other, and they can never be superimposed on each other. Therefore, they're considered different molecules. And they have very, very similar boiling points and other physical properties, same molecular weights and everything. But one major difference is the way they act oftentimes in our bodies. So because they're mirror images of each other, molecule A might bind onto a receptor on our cells, but molecule B might not. And so they can have two different effects. Some might, this one might not have an effect at all, and this one might have the effect that we desire. So to learn more about that, you're going to take a look at the introductory video here that goes over a common medicinal molecule in nasal sprays. Then you'll go over these 2 videos here that goes over the idea of enantiomers in a bit more detail. This one here is a little bit of a molecular model video that demos the superimposition idea I just mentioned. One more thing to really mention before you go into those videos is, again, in order for enantiomers to be possible, you need to have a carbon where you have 4 different groups attached to it. None of these groups can replicate. So CH3, OH, H, COOH, these are 4 different groups connected to that carbon. And as a result of that, you can have a mirror image where you can't superimpose it onto its mirror image specifically. And so a carbon that has 4 different groups connected to it is called chiral. So if you have a chiral carbon in a molecule, then the likelihood is that that molecule can have a mirror image version of itself. In other words, it can have enantiomers. So that just goes to show that there's a great deal of variety in organic molecules, not just based on the fact that you can have different chain lengths, but which is related to this, but because of these isomers. So you can have constitutional isomers where you have different bonding sequences with the same molecular formula. So the same set of atoms is being used to make a variety of different molecules with different bonding sequences. But then even if you don't have different bonding sequences, you could have the same bonding order, but you have different spatial arrangements, and so you get your stereoisomers. And then within there, it could simply be the spatial arrangement around a double bond, or it could be, if you don't even have that different spatial arrangement, you might have a spatial arrangement that's due to being a mirror image of another molecule. So it just goes to show, from a limited amount of atoms, you can make a great deal of molecules because of this idea of isomerism. So please watch this video here for a more real-world example, along with these 2 videos here for more details on enantiomers, with this video here showing you a demo with a model kit. And later on, you'll get to play with model kits to see if you can build different isomers of molecules.